There we go. Right? Yeah. Right? Alright, well, let's just go through the motion of copying over FreeRTOS. I want that there. Source? No. It should be source though, because I don't like mixing the project files. No, whatever. This already has FreeRTOS config in it, which should be good enough for what I'm doing. It's already set up for this chip, so I don't need to do anything with it. Is it too loud? Or I tested it a while ago, but I don't know how it is now. Third party FreeRTOS. Yeah, let's just go on a copying spree. I probably want circular buffer. I want main and main RTOS. SD stuff I'll just leave for the time being. And I already have a startup. Yes. Refresh. So now I need to add include. This is always a pain. Just copying stuff over. Let's make sure I didn't forget anything. I don't even have a main simple anymore. I'm just gonna go straight into RTOS. And now, well, I guess since this is just a test of sorts, I could just keep my two tasks. I guess this comes from my FATFS test program, which basically just has a producer and consumer task. Spark. Oh, wait. It's so the board that I'm using, this guy right here is TI's Cortex M4 development board. And then this here is the GPS unit. This guy right here. And it's called NavSpark. Yes. All right. So what I'm basically going to do is set up a task which collects, maybe I should make a to-do other file to-do. Create push data to consumer task, and the consumer task will be something that would either transform the data or push it on to something else, like, I don't know, like an SD card or something. Alright. Getting distracted, but it's alright. So why don't I get rid of this code here, right? So what I want to do, I want to steal my code from the greater initialization in here, and then put it okay, UART0 is for something else. It's for the serial to USB. So right now, this guy is plugged into a USB. I don't know if you can see it. It's right here. It's plugged into USB, and I can output like printfs and stuff using the 0-channel UART. But what I want for the GPS is UART1. That's where this is plugged in right now. So that'll allow me to collect the stream coming in. And this is actually, I can see this data coming from the GPS right now, because it is plugged into USB as well, and it has its own USB or serial to USB converter. So it shows up as port 12. So yeah, so I'll basically just copy over the UART1 initializer right here. Let's put that here. And I know it's at 1150-200 because of the spec. Should be in here somewhere. There. I guess it's a little hidden, but the manual on setting the module up for RTK-lib says 1150-200. Okay. So we have UART1. I'll just get rid of this stuff for now. Actually using this? Nope. Not using that either. So just write task, and I'll get rid of that as well. So now what I'm going to do is steal code from my UART task. Like I was saying before, this is originally intended for outputting to Bluetooth module. So data comes in and then you output it to Bluetooth, and then you can forward it onto like a phone or something. But what I want to do is collect the UART data coming in, my GPS data, and then I'll do something with it. I don't need this yet. This will be for eventually I'll probably use my DMA transfer code. So originally this was for a DMA transferred UFC card, but what I have is this nifty little library. Well, there's DMA mem copy, but then there's also zero copy free RTOS, which I use to be able to pass data between tasks without having to actually copy it explicitly for each task. So it gives the tasks the choice of whether they want to copy it or just read a value and do something based on the value. And I will implement that eventually because that's why I wrote it. But right now, the title of this stream is GPS UART, so I'll just do that. With as few lines as possible. So yeah, let's get rid of those for now. What we're left with is task parameters. I want to fill this in with something. Probably a buffer. Probably not SD struct. Semaphore, maybe. Let's just call it private producer task for now. That's what it's called up here, right? Yeah. We just call it that and then implement it below. And this will be where the GPS data is collected. Except I need to set up okay, so this isn't really useful because I'm not actually using the interrupt handlers in here. If I go to greater startup, and if I look here at the UART1, here, yeah, I'm not actually using the UART interrupt. That sucks because I can't steal the code from it. But I do have some code for that somewhere. Where would that be? I forgot all about all this ping pong buffer stuff that I had. Okay, so I actually did find some code that I wrote a while back, and it uses, it's cool because it uses a ping pong buffer. So the GPS fills up one buffer, and then that buffer gets well, an interrupt triggers, and then you can service that buffer while another buffer is being filled. So you don't need to use the same buffer continuously, because that can lead to missed data. So I think I want to use this, but I didn't actually implement it in an RTOS setting, which could be problematic, because I need to wonder if I can just I'll just roll with it. Alright, so let's set up. So let's actually do a separate file for the GPS task. New folder, tasks. And let's do source file, GPS. Problem with just calling it GPS is that there's different protocols that you can use on top of UART for GPS. And the most common is actually NMEA, which I'm not using here because the NavSpark doesn't use NMEA, or it can, but the point of the NavSpark is to be able to access data that isn't provided by NMEA to get more accurate GPS results. So that's why we're using this binary SkyTrack protocol. So maybe I should just call it I'll just call it GPS task for now. .c. And then I'll make a header as well. And how I usually do these tasks, if I pull up, so I make an init function which is exposed to the main function, and that allows me to initialize it and assign buffers that I'll use later to transfer data from one task to another. So why don't I just add this stuff as well for now? So GPS task. So I don't actually do any hardware configuration here. That's all handled in main. Because I'm keeping this more or less chipset agnostic. But I do... Oh man. I do need to not only initialize it. Okay, so at first I was just going to do it in all of it in my main file, just because it would be easier. But since I need to do my interrupt handling, it's going to really clutter up the main. So I'm better off just making a separate file now, and then having an easier time implementing the GPS stuff. But first, where was I? First, I need to get the task initializer in place, which also requires me to set up the task struct that'll pass like my buffer information. So if I look at this task parameters, I should actually this code that I wrote before took a while to sort of design and set up. That's why I'm pausing now, because it's not trivial just to copy it over and run with it. Like, these buffers hold pointers to shared buffers that each task, I believe, somewhere it's defined how they know which of the buffers to use. I guess it's just hard-coded here, but ideally you would pass that as well so that they know to take the zero index buffer as the one that they use for passing data around. Well, I'll just keep copying stuff over and see how far it gets me. It's all boilerplate code, but as long as it gets the program working. Is that what I call it? Oh, yeah, producer task. No, let's just do this. It'll be better in the long run. I don't actually have task parameters copied over. There's extra stuff in here like the bus mutex. That's for like I2C and SPI modules that share the same bus, so that you can share the bus across multiple tasks and they can use it when it's their turn. But I don't really need that here since it's a serial line and it's just the GPS. But what I do need is, apart from this initializer task, I need the actual task. And then how this works is that once the RQS scheduler starts up, the task itself, it copies over the elements of the struct into its own local pointers, and then, like I said, this is transmitting out, so it's not necessarily what I need, but at least it's something that I can copy from where I won't necessarily get confused. But actually, what I do really want is this stuff. So this stuff I wrote a long time ago for some sample program. And I'll actually Because this doesn't consider the ping pong RX. So I'll get rid of this. And look there. The only issue with this now, though, is that that these buffers that they're being collected into are what I want to put the interrupt handlers in my GPS file, not in my main file. So in order to expose these buffers to the interrupts, I'm actually probably going to need to move these over. So why don't I just what did I call this again? Configure UART1. So maybe I'll just call it configure.
You're listening to Summa FM from San Francisco Internet Radio,
GPS,
commercial free and listener supported. Help us out, sign up for a monthly payment plan.
And then
as little
what
as
I can
$1
do,
or pretty much as much you want to give to us automatically each month. We would really appreciate the support and
is
help
I
keep
can
us on the air.
move
Thanks.
Fruit Salad, listener-supported commercial-free radio from Soma FM.
Should I just move all of it? No. I probably want to at least keep all of the non-DMA stuff. So like, starting from here on down, right? This will probably change, but I'm just trying to think how best to do this right now. Because these definitely I want to have defined in the GPS task itself. So right now I'm just copying over code from old programs. I'll probably end up changing stuff, but I just want to make sure I can compile without failing. Yes, that should be good. And now I want the interrupt handler. Where is it? UART1 int handler. Oh, here it is. This is not terrible. I just have a bunch of commented stuff. So now I'll go in and change that. So this is my my list of interrupt handlers, and one of these guys is UART1 right here. I'm just going to change that to GPS int handler. And that needs to be included somewhere. Alright, let's clean this up. We don't need the comments. No, I won't be using TX. I don't need that. Basically, we're just receiving data from this module. We're never going to send stuff to it. So what this does, so this is defined. Yeah, so this is just defined as a global variable. And in the non-RTOS code, it basically just pulls the variable to see if it should service that buffer, if it has data in it, and that'll happen in this infinite for loop. And what these will become, what happened? These service buffer flags will become semaphores eventually, and then we'll just be able to sit on the semaphore, and then once the GPS triggers the interrupt, by filling up the buffer, it'll trigger the semaphore, which will trigger this task to handle the buffer. I have code in here for throwing a semaphore from an interrupt. Is it in here? Oh, it's actually in my driver code. Do I have something here? Nope. Alright, I'll dig a little deeper. Yeah, it should be in FATFS. This guy. There we go. So you can see this flag where this is set up to use both just a simple program and RTOS, where if it's just a simple program, there's this DMA complete flag, which is similarly pulled in the infinite loop to see if DMA transfer completed. Whereas with the RTOS, there's this semaphore that we want to use, and that'll happen I don't remember how best to handle a ping pong interrupt with a semaphore. Yeah, so I think regardless of whether it's the A or the B buffer that triggered, I think we should just throw the same semaphore and go from there. So alright, I don't know if this is the most elegant way to have done this, but this UL mode checks the primary buffer, the A buffer, to see if that one filled up, and then if UL mode is no, I probably didn't include something. Yep. I gotta check my includes later. But anyway, UL mode will be true. This will be mode stop if the A buffer is filled. Otherwise, it'll just fall through to the second check, which checks the alt buffer, which is basically just the B buffer. And then if that's full, it will, it'll signify that the B buffer got filled. And as long as the interrupt is thrown, we should be able to assume that one or the other had thrown it, and not neither. Unless, well, there is an interrupt for UART errors, I believe. Maybe it's just DMA errors. Yeah, UDMA error. So that would be another interrupt vector that would trigger if, like, the DMA transfer got corrupted or something happened where it didn't complete successfully to push the interrupt into the module level, where you could say the UART triggered, or the DMA triggered the UART interrupt, which is what's happening here. So there's actually like a UART error interrupt. It's just, it triggers once the UART has something to interrupt on, and in this case it'll be the DMA transfer completing. Yeah, I'm realizing that I'm incorporating a lot of different concepts and features into just a simple application, or what's supposed to be a simple application. But as I've, written like test programs and learned how DMA stuff like works over the months or whatever, this is pretty much the end result of what I would want my program to be doing. I wouldn't want to have like an interrupt being triggered for every single character that's being thrown, which is how a very rudimentary UART interrupt would operate. So DMA allows us to collect a set of bytes before throwing the interrupt, and that gives our system a lot more time to do stuff and not have to handle interrupts every fraction of a second. So there is a lot of time just dedicated to setting everything up, because it's not just like a simple program. But that's alright. Yeah, I guess if this was a stream that was more geared towards like teaching, then I would probably be more apt to setting up, much simpler test cases or programs that can easily be parsed and sort of built on top of. But what I'm doing right now is something that I'll actually be using later for GPS collection, and I want to pretty much throw every feature that I can at it, because I know how much it sucks trying to implement something like an interrupt that throws for every character. It's not a very wise way to handle serial. So what do we have right now? We have the UDMA stuff, initialization set up, and hopefully this eventually will. Why don't we handle that right now?
I got you. I can't give you anything but love.
I should have this stuff.
I got you. I can't give you anything.
Oh, software root probably isn't set properly. Alright, let's set that then. That's probably set to my D drive. Nope. Where is it here? Alright, so there's this definition right here. Gonna need both of these. Build. Crap. Well, I use the same variables throughout. I know where the include directory is, but I want to keep my... What the hell? Probably gonna have to include those as well. Well, maybe not yet. But these for sure I need. Maybe I'll just try and memorize it. Original project root, software root. I don't know why I can't just copy paste. Alright, original project root. No, you forgot what it was. Awesome. Well, actually it doesn't have an original project root because I started this project from scratch and not from one of the sample projects. But I suppose I could just try and go into TiVoWare, examples, boards, and then this is the 123 GLX, and then we'll just do like, yeah, free RTOS demo. Is it CCS? We'll find out in a sec. Alright, that's original project root. Now I need software root, which is like whoops. Probably needs backslash. And I forgot how many levels deep it was. It's like examples, boards, GLX, free RTOS, and then maybe CCS. Let's try 4 for now. And I wish I could just copy paste this stuff. It would be so much easier. Alright, edit. Yeah, it is CCS. Alright. And then project root is... Well, I should have just copy pasted this. Why didn't I do that? But yeah, this for sure is boards 123 GLX, free RTOS, CCS. Change this first. 64. Yep. Alright, so that's set. But that's not the end of it. I still need to do something else. Where'd it go? There it is. So it's actually exactly the same thing, but for some reason it doesn't transfer over from the linked resources section. So I don't think I can copy this. Yeah, no. Oh, okay. And then, what is it? Software. Sweet. That was easy. Alright, so now I should be able to click on these guys and then they'll follow. Yep. Thanks to whoever just followed me. I thought I had a notifier thingy set up, but apparently it didn't trigger. Anyway, thanks. So now I have what? I have all my includes. I have the DMA configurator. I have the interrupt handler. I don't yet have the semaphore, which I'll get to. But really, just for now, I could just implement a delay.
Use your last breath to let your soul rise to eternity.
So I could just implement a delay of like something less than, well, something greater than 0, but something less than the time that it would take to fill up a buffer, so that we don't fall behind on servicing the buffer. And if we wanted to do the math, which I guess we might as well, so 115200 divided by 8 is 14k bytes per second. And if I have a buffer size of 512, that means that so 512 over 14400 is 35 milliseconds. Is that right? 35 milliseconds per byte. Yeah. So that would mean, well, wait, but we want the total time for a single buffer. What am I doing? Alright, I'm mathing wrong. So 14 kilobytes per second. Yeah, so I want to divide that by 512, right?
I have wasted my time.
No, I want to divide. No, that was for the entire buffer because it was 512 divided by 14400. Yeah, that's why it sounded wrong because I thought it was calculating per character. But no, 14K is per character. 35 milliseconds is for the entire buffer. So I want to sample, I don't know, every 10 milliseconds or something. So then what I can do is I can just do like if this, then this, else if b, then this. And since these only set it to 1, I need to make sure I set it to 0. And there's obvious implications for race conditions, but we'll deal with that later. Buffer 8 is 0. Alright, so now we're servicing the buffer, or the semaphore, even though it's not actually a semaphore at the moment. So there's that. And what do I have in here? I have the initializer, and I have, is this right? Yeah. Let's get rid of this stuff.
Do things as you were taught and free yourself from the world.
Actually, I really don't care about task parameters and stuff at the moment. I just want to see the interrupt trigger and then see it go to my task. So yeah, if I can just do like GPS task. So I have this task set up with just null parameters. I don't need this SD struct. I don't need this either. So I have a set of task parameters. Right? No, it's just one task parameter. I have one task parameter for my GPS task that I'm passing in, and currently I don't care about any of it because I'm not using a semaphore yet, and I won't be sharing the semaphore anyway. I'll be sharing the buffers. So I have all of that. Will it fail a compile? Probably. That must mean that something isn't defined correctly. But what? I think well, I for sure need some stuff in here, right? That does seem no. What am I not accounting for? I probably need to set up a stack, but that's not why I'm getting the error. I'll just do that right now anyway. Linker, options. Yeah, so I use 0 for heap and then 1024 for stack. That should be sufficient. I guess it's currently set to 512, but I'll just bump it up. And then in startup, right? Or is it? No, I think it's in here. My linker. Yeah, in here I manually set the stack position. Yeah, see in here it's hard coded to 512. Just set that to stack size. And that should work. Then just for posterity, if I ever implement FATFS, there's some extra. How did I fix that? Oh, I reduced the heat. But I was going to realign. Or did I realign it? Well, either way, I was running into to stack size issues when I was trying to use both FATFS as well as FreeRTOS. They weren't fitting in the space that the chip provides. And I solved it by reducing the heap size for FreeRTOS. But moving these values around is also another way to, well, at least if you're splitting up your flash space. This doesn't really do that, but if you were, then you would want to add your own memory locations for the linker. Anyway, back to trying to figure out this include path error. I should have just copied over a sample program because you run into all sorts of weird project compiler settings when you start a project from scratch. I've actually never seen this one before, so there you go. Maybe if we look at the actual output. Oh. Yeah, something is null. What's null? Third party FreeRTOS. Whatever comes before FreeRTOS is null. Oh, unsurprisingly, FatFS. I don't have FatFS yet. That's what I get for copying stuff randomly. Alright. Yeah, so I don't... Let's see. Task title. So on the other project I created this priorities header so that I could have one place for all of the priorities to go. And actually maybe I'll just define this up above. But I don't think I'm gonna have that. Not yet anyway. So I'll just get rid of this. And define it like right here. And that'll be like 1, I guess. So it'll have a priority of task idle, which is like 0, I think. Yeah. It's just the base priority value plus 1. So that it'll trigger before the idle, but not something with like a priority task of 2. And that I usually keep, well, I guess there are different thoughts on the design, but usually what I like to do is I like to design the data consumers or the data producers, which is what this is technically. I like to design those so that if the system is being bogged down, then we might lose data coming from the GPS, but at least we don't mess up like writing to the SD card, which is like way more critical. So that the SD card in effect will have a higher priority value than the GPS value because it's a consumer of the data. So it needs to just handle the data and then be done with it. Thanks for the follow, Battle. I don't know why my stupid... Look at this guy. I have... No, not following. Notification widgets. It says it's set up, right? If I do test, that shows up on the stream. So why doesn't it show up when someone actually follows me? Or maybe, oh shit, I wonder if I'm supposed to enable this. Okay, that makes more sense. Someone should follow me so I can find out if that's what I was needing. Anyway. Oh, I just now got the notification for Battle following me. Oh. Thanks, Mr. Love Pickle. It does work now. Alright. So I only have a couple of errors. I just commented out this stuff I certainly don't need. And then, yeah, so I need to make this included. How do I normally do that? I think I normally just include the task header, but I'll verify that. Start out. Oh. Okay. I guess it gets its own definition in the vector interrupt vector file. So this will be extern void UPS int void. No. What is it? UPS int handler. Wait. What? No, I want... Oops. Int UART1 is... So like a UART1. Where's that coming from? I don't remember. Nope. Control H. Yeah. Alright, so this was another facet of all the project includes that I was trying to avoid. But this is under the linked resources section. I guess if I want to do it like everything else, I have to go in and make the directories. Yeah, URSTDIO. No, of course I can't leave that open. Alright. Folder. See if I can remember how to do this. New .tar file. No. New other. Shit, I don't remember how to do this. Import. Import. I was avoiding how to do this, or avoiding doing this because I couldn't remember how to do it.
Fruit salad, low in calories,
But
high in
looks
fat.
like I'm gonna have to figure it out. So maybe I'll do this on stream. TI, CCS, linked resources.
Traveling to where you are. I wonder if you're near, if you're far.
Right click on a project, add
You
files.
wanted me to in the street.
Dialog box will link 2 files.
Now we're wondering. Keep it down.
And then that'll be in my Tiva install directory under utils.
Keep it down.
URSTDIO. What was the other one? RGB? LED? Something? Relative to I wonder if I could drag and drop. Try that instead. It's not. Alright. I'll just try and go ahead with this then. CDIO. Link files relative to not project work, software. Ah. But it's not in the utils directory. Okay, maybe I can just there. Yeah, nothing is actually created in the utils, but it's nice to have some sort of context as to where those files are coming from. And if I click on them, I get the resolve file coming from the actual, like they're actually coming from this directory, but they're being linked to this project via these linked resources. Actually, if I go into here now and then look at my linked resources, these show up. And that should be identical to the others. Variable, relative path, yeah. And for this one I have this SD card driver that has its own directory because it's like a Git repository. But then this sample project pulls it in via this linked resource. So that's sort of something that took a while for me to get used to in Eclipse, but I guess it serves its purpose. You can pull files in from remote locations and then reuse them without having to copy them over, much like I'm not doing with FreeRTOS, so I should be doing. So yeah, now I should have UART1, or the int UART1. Wait. Yeah. Yeah, I don't want this yet. But I do want this. Where is that coming from? Wait, no. Okay. Let's fix this first. I'm not creating the task in here anymore. It's being created in here. Is there anything different between those? No. Yeah, just the formatting. I actually kind of like this formatting a little better. Whatever. Let's leave this. Alright. So now that's gone. And in its place I will do... I just put out what the name is. GPS task init. And this right now is only pulling in. Alright, we don't care about task parameters right now, it's just toss in null. And then null there, null here. And now this will initialize our task, and then once we run the scheduler, we should hop into here. So if we at least get that far right now, that'd be good. What am I missing? These are coming from GPIO, I thought. Apparently not. Alright, let's check. Do a global search. map. I was close. But then why? I have pin map on here. Why isn't it resolving? They are different chipsets. Why would that be? So basically I looked at that pin map include, and then my the define that I wanted was commented out because of a mismatch in which chip I was using. But here I'm using 123 G8 and GH6PM. Here I should be using the same thing. Yes. So why would that be? Yeah, let's do a quick calling of all these other guys. Did I have to define it manually? Oh, okay. Yeah, there's more crap that comes with these sample projects that I forgot about. It's wouldn't be in the linker, although I feel like there is something that I'm missing in the linker. Do I have driver lib? I bet I don't. Nope. Alright, so let's add driver lib quick. So I know that'll give me troubles later. Alright, driver lib's in. Now I need the definitions, preprocessor stuff. There we go. And it'll be the same for release, except without debug. Right? Yep. Yeah, there's just so much boilerplate that goes into just setting up your projects. Like, I have all the code, you know, written. It's just not assembled and the project isn't configured correctly. But now things are more or less coming together. So I can get a compilation without failure. What? I have software root included. Both, right? Yeah. And I have my Yes. Build variables. Both debug and release. And they seem correct. What else am I missing? Let's do this too. That's right. 12 jobs. What is missing? Code path. Alright. I have this base directory as an include path, and then from there it should be able to resolve all of this stuff, which if we look at this, you know, the base path corresponds to like driver lib, pin map, and we can also access it from the IDE find. So why is this throwing so many errors? I assume I have UD name here. Is that not the case? Maybe that isn't the case. Okay. Yeah, because I copied that over from main RTOS. That would do it. So now I need to steal those includes from Grader again, probably. Right? Maybe not. So I'll just do it by hand. Driver line. Right. Yeah. Alright, so that's taken care of. That, maybe that's actually everything. Except for this guy. Hardware ints. Wait, did I not? Did I delete that? Oh no, it's GPS task size. Which is that? What? Oh no, I just defined the priority. Now I need the stack size, which. Alright. I think I usually just do it right here. There's a default stack size. They usually just define everything. Minimal stack size. Alright, now everything should more or less be in place. Since I still have that webcam. Yeah, I have that webcam pointing at the chip. So actually, what I can do is steal more code from FATFS DMA test for the pin right. Yeah, except I want this toggle. So this will toggle every time this guy gets written, and then no, actually, let's make it look cooler. So to achieve the true ping pong effect, I'll do one goes on here, and then two goes off here. Hopefully I'm not using these somewhere else. But then here, I'll do the opposite. 0 here and 1 here. So that it'll kind of flash like back and forth between the colors. And that's how we'll know that the ping pong is working correctly. Still feel like let's look for this guy quick. Just to make sure I'm not using it anywhere else. Oh, that's right. I don't need this. Alright, so they're all configured in main, which is fine. Then I'm using them in here. I think I need to add something. No? Oh, oops. Sure. Disk timer proc. Yeah, stuff left over from the other program. Gotta call all this stuff out. Figure DMA. I don't need it, right? So I think configure DMA. Oh, let's make sure. Oh, I don't have the I don't have the control table set up yet. Yeah, okay. Well, at least I didn't delete this. So now I can just add that and then uncomment the part about setting the control. But one of my last streams was all about getting this control table out of main, and now I want to put it back in there. So where do I get that? I can get it from a couple places. This should work. Control. Yeah, so for these other examples, I have the control table for the DMA configurations. I have them in their own driver files. But for this, there will be multiple drivers using the same control table, which is why they need to go in main, because that's where it'll get initialized. So I'll just put that right here. But where are my other, do I have any like global variables? Not really. Alright. As long as it's before DMA. What? I don't know why it was PUI. Maybe that was just something I did to differentiate the two. Yeah, that's probably what it was. Alright. Oh, where am I defining this? This is what I was talking about before with defining your own memory locations in the linker. This UC heap was something that I defined, but how does that make its way over here? Do I want this? Yeah, actually I probably do. Yeah, so why don't I'll just go through the motions of defining the extra memory location. It's just this one line here. Wait, did I just build this? Why would it be getting problems with that? Most driver load isn't working correctly. Seems like it is though. There you go. Alright, let's see if I can figure this out before I need to go to sleep. It's getting late. Yeah, I guess I'm not really sure where this is coming from. Oh. this guy. Okay, so I guess, yeah, it's depending on me to define it, which obviously I didn't do. So let's say this is in main simple. Maybe I'll just put this into main. Sure, why not? Ugh. Why doesn't know it types? No STD in. Sorry. It's getting late. There. Alright. Before the program crashes, let's try and set a breakpoint. Well, I guess we have the LEDs, but I just want to make sure. Oh, it's already set. Alright, let's go. Damn it. Alright, so we hit the fault interrupt, which means something, probably RTOS didn't configure properly. What would that be? Oh, yeah, I didn't change my startup, my interrupt vector code. That is likely the problem. It's all free. Whoops. Wrong program. There we go. Alright. So it was originally initialized to 0, But since it's 1 now, that means we successfully hit the interrupt. And now it enters into here and does its thing. Hopefully the other webcam will show. Well, alright, something must have messed up. Let's try it again. The LED should be blinking different colors, but I wonder if my pausing the operation messed up the interrupt. Let's try it again. There we go. And the data rate is actually slow enough so that you can see the LED change color. So to recap, what's happening is these bytes, they're shown in ASCII-X here, but these bytes are streaming into the microcontroller via the UART1 port, and every time it fills up 512 bytes worth of data, the interrupt gets triggered, 512 being the definition of the RxBuff here. Every time one of those ping pong buffers fills up, the interrupt gets called, and then since I'm doing this ping pong method, it first checks the A buffer, the ping buffer, to see if that's the one that got filled up, and if it is, it reinitializes the channel. Or actually what it does is it switches it over to use the B buffer, and then it sets this flag to say service the A buffer while the B buffer is filling up. And then likewise, once the B buffer fills up, it re-enters the interrupt handler, and then it goes through this because it's not the A buffer, and then it sees this, and it sees that the B buffer is full, and then similar to A, it triggers the B, and then in the task I have the checks for A and B. Then once it's done servicing, in this case it's just toggling an LED every time it services, it resets the flag. And like I was saying before, obviously, you can't just switch a flag on and off and expect that you're going to have ample amount of time before an interrupt triggers again. Because if I were to ramp this all the way down to like, oh, I don't know, 4 bytes or something, then we're starting to get into like this will go to service, and then while it's servicing, the interrupt will trigger again, and there's no check to see if this is still 1, if it got reset or not. So this will just trigger and then go to 1 again, and then what you end up with over here is probably data corruption. So this isn't really a production ready method, it's just sort of to show how you can communicate with the interrupt to handle data outside of the interrupt within an RQS environment. And next what I'll want to do is replace these guys similar to, where was that? I think it was in my driver. yeah, similar to this. So this works similarly to what I have now, where it sets a variable to 1. But eventually I want to replace it with this semaphore give, so that like this project here, the right task, is it? Wait, what am I doing? No, it's within here. Yeah. So similarly, I will be waiting on this semaphore in my task, and once the interrupt throws it, as it does in here, then I'll be able to resume operation in my task. So I'll basically, where am I? GPS. So I'll replace this. So that'll become semaphores, and then what I'll be able to do is, while I'm waiting for the interrupt to trigger, other tasks can run, so that I don't need this polling method, because polling isn't that ideal either. At least in this case, where I'll likely have other tasks and data sources coming in that I'll need to handle concurrently. So that doesn't really talk about what this data actually means, but I didn't really want to get too deep into that anyway, because the firmware won't actually be processing any of the data. It'll likely just be storing the data to file, or pushing it over Bluetooth to my computer, which I'll probably run RTKlib to process it. Then I'll be able to do some like precision GPS correction and stuff, which is what this module is intended for. It gives you extra parameters like the pseudo range and the it's been a while. The Doppler frequency, the Doppler shift. It's basically stuff that you can use to correct what your GPS thinks is its current location by using correction values given by like NOAA and NASA, I think, mainly NASA. And then you can end up with like centimeter level accuracy in your GPS. But right now we're just storing the raw data, or we're shooting for storing the raw data and then post-processing it later. But yeah, it's working, and it only took a couple hours, I guess. And it is 11 p.m. almost on the dot, so I think I'm gonna leave it here. Maybe if I have time on Saturday, I might work on this again. Otherwise, I'll go back to my SD card stuff. I know I have a few more tasks there that I want to get to. But yeah, tonight was fun. Try and do it again on Saturday.